Hi, everyone. This is the DeSci Labs community call for the week of October 24th. Today, we're going to be talking about gateways. But before that, just a quick update on everything DeSci Labs. For starters, we have launched the Node Stewards program that is currently just getting kicked off. John J. Ringo on the Discord and Carla Ost on Discord are currently running that program. So if you have any questions about Node Stewards, please feel free to reach out to them. And before we start the actual call today, John will give just a quick overview of what the program is. There are a couple other conferences that are happening. So we're going to be attending the Fair Digital Objects Conference in Leiden over the course of this week. There are a variety of other events in Lisbon, including, I guess, kind of centered around Lab Week and funding the Commons. And then beyond that, there will be a presentation in Atlanta, Georgia, around DeSci nodes and how that plays into some of the compute over data initiatives that Bakliyao is doing. So all of that's exciting stuff. Then actually, John, if you want to take it real quick and just give a brief description of what the Node Stewards program is and how someone can get involved, I think that would be really helpful.
Sure. Very brief. We are trying to make 100 research objects using DeSci nodes, which is the software everyone's seen in the demos. We're going to go out, find some research that highlights the software's capabilities, build nodes out of them with hopefully the researchers' permission. Well, definitely their permission, but hopefully their help. And then we're going to show it off. We want to highlight fantastic open science and impactful research through the ages. And if you want to help do this, it's going to be a lot of fun. There's a whole group of people doing it. Feel free to reach out to me or Carl here on Discord, and we'll get started. We'll get you hooked up to the right channels you got to be in. That's the brief rundown.
Awesome. Thanks, John. Philip, Carla, Chris, anything that y'all want to talk about in the intro before we get started on gateways?
Yeah, I just wanted to echo what John said. So the Node Stewards program is, I think it's going to be one of our most important tools for actually onboarding the scientific community at large. And ideally, what we're looking for there are researchers from fields that do quantitative work, empirical work, that have important data to share. And we're just having a research object is going to create a much better user experience. It's going to be useful for other scientists by enabling them to check the reproducibility of work and also directly be able to pull the data, see the code, all of that stuff. And yeah, so we're primarily targeting really high quality work from fields and from laboratories and from people that are doing high quality empirical science. And there's so much exciting, cool stuff going on in science in so many different fields. I mean, I know from economics and from genetics and so on and so forth that there is a lot of people and a lot of fantastic work out there that we could tap into. But I'm really, really curious also to see from what is out there in other fields that I personally don't have a good overview yet. So we do have a feeling that there's a lot of work happening in the natural sciences and engineering that is going to be relevant for that. And yeah, it's going to be exciting.
Oh yeah, and I can second that. With machine learning is also going to be an incredibly interesting field because we get to put these models in an open state repository, and that's going to be a step forward. Essentially, being able to access these models, to democratize them, to prevent different types of censorships that can happen. So I think it's going to be really, really exciting for large language models and all sorts of computational based research that benefits a lot from working either on large data sets or having complex code bases that interact with the research objects. So this is going to be an incredibly exciting opportunity to bring those on our system.
Fantastic.
Yeah, so yeah, let's get started.
Right.
There's some interesting news I'd like to start with before we talk about gateways. There was a really, I don't know if all of you are familiar with eLife. eLife is a really interesting journal in the life sciences. It's been founded, I think, probably a decade ago or so. It's been funded by the Wellcome Trust. It's mostly people from Oxford University and these other English universities. They've always been somewhat at the forefront of experimenting with novel models of publication, trying to essentially take a hard stance against the type of business models that the journals have now in scientific publishing. It's the editor-in-chief, Michael Eisen, has a Twitter avatar. It's like, journals are not real, so you could quite clearly get a good idea of the type of stance that these people take. And they've been really at the forefront of experimenting with different models. So they were one of the first communities to propose that journals should essentially be overlays, preprint platform overlays. All right, so you go on a preprint platform and you can click on a piece of published research, and let's say you can click and see, hey, assessments by the scientific community. And then we don't really need journals. What we need are overlays on top of preprint platform. Yeah. And so it's been a long story, the adventures of eLife, which is quite a fascinating one. They have been, at some point, I believe in their arc, a lot of these ideals were kind of set aside for a time because the journal was trying to build up legitimacy, build up an impact factor, and they had quite of a delicate line to tread here, because on one side they were like, okay, so how do we attract submissions from authors? Well, we need an impact factor. But on the other side, we're against impact factor. We don't like impact factors. We don't like how the journals are organized today. So what do we do about it? So it was they were essentially navigating this this difficult line between these two impetuses. They ended up getting an impact factor, which was quite high at the time. It was 9 or something. So it kind of positioned eLife as like one of the very competitive journals in the life sciences. And as a result of having an impact factor, well, it started to attract a lot of high quality submissions. Prefacing that it already had high quality submissions in order to obtain such an impact factor. And a lot of that is owing to the incredible network of editors and people who've been spearheading eLife with their networks. And so they got this impact factor and they started building this reputation. And just last week, eLife stated, hey, we're going to stop accepting or rejecting papers. We are going back to our roots as being an overlay journal. And we're not even going to make a binary decision about whether it's accepted or refused. The only thing we're going to do is our editors will only evaluate the scientific merit of the work, not the novelty. And they will not produce a binary decision. They will produce a research assessment. So that means that every paper published in eLife from now on is going to have an editorial assessment, which is essentially conspicuously placed on the front page of that article that's been submitted for review by eLife. So that's the idea. They want to get rid of dichotomies, and they want to introduce this more nuanced editorial assessment. And that editorial assessment is essentially born out of the peer review report and the experience of the editors, these very experienced scientific editors that they have. And the authors are not required to respond to peer reviewers, right? They can respond and incorporate whatever comments they want. It is completely optional. What it can do is that if they do incorporate comments of the peer reviewers, it can change the editorial assessment down the line. So that was essentially a small earthquake in the world of academic publishing. Well, we could actually say a big earthquake. It's been all over Twitter. There was some really interesting discussions happening on both sides, right? So you had two broad movements, appearing. You had people saying, well, this is great. This is really how the future of science should be organized. eLife is doing it right. That was one of the movement. I would call that the more activist movement. Another movement was like, hey, wait a second. How are we going to deal with cognitive load as scientists? I mean, there's so many garbage papers published all the time. How do we tell the good ones from the bad one if we don't have a binary shortcut, right, to perform triage at scale? And so there's that whole branch of people thinking about cognitive load. There was even Sam Gershman, a really cool neuroscientist, who called, hey, we should have a cognitive science of to essentially optimize over cognitive load for researchers, because there's way too many papers to read, not enough time, it's very hard to tell what I should be reading. So you had quite a big clusters of people engaged in that conversation, talking about how we're going to reduce cognitive load. And on the other end of the spectrum, you had a couple of scientists who just went out there and they were outraged, and it was like, Eli pull a bait and switch on me. I've sent my best work, in this paper for all these years, and now they just bait and switched, and they tricked me. And what's happening is that my work is what's going to happen? What are funders going to think about it? What is my university going to think about it? If my papers aren't accepted or not accepted, I mean, how is the entire apparatus of science that funds my lab going to react to that? And what's going to happen if Eli's reputation goes down, as a result of this change, and I have all of my best works already published in Eli? Well, what does that mean, from our career? And so you had all of these, there's like the third cluster of responses that was really, really entertaining and actually quite crazy, to see this happening. I mean, all of this just highlights how much the scientific community is sensitive to even changing a single parameter of the system, right? You change one parameter, which is let's not have a accept reject, but rather an editorial assessment. And that creates, these essentially shockwaves, right, in those communities as they try to figure out, how to cope with the cognitive load, what this means in terms of funding, what this means in terms of the reputation of my lab, and so on and so forth, right? So really interesting conversation. I encourage people who are interested in, innovations and drama around scientific publishing to kind of dive into those discussions. They're really engaging. And personally, I'm very much in awe of what eLife is trying to do, right? They've been at the forefront of trying to shake the system of scientific publishing for many years now. And I think this is a valiant effort.
Yeah, it's super bold and really exciting. So one of the questions in my mind is how their impact factor is going to react. And I wouldn't be surprised if the impact factor actually remains stable or maybe even goes up as a result of this. It would be really cool to have a betting market about this, but it's a really, really bold and exciting experiment.
Can it? I think, it could absolutely nuke their impact factor as well. Think about it. Every paper that gets submitted to eLife, there's no such thing as a rejection. So they're all published on the website, even the ones that are terribly flawed, right? The thing that sets those apart is that if you spend the time to read the editorial assessment, you'll understand that they're flawed. So what does that mean as an author? That means you go on that website and you have to do additional reading before you have the assurance that you can cite something, quote unquote, safely, right? I'm just really putting big quotes around that, right? Because there's no such thing as citing, something safely. And so that could have, that the question is then like, well, what is an eLife published paper? If they remove this choice, what they're essentially doing is they're removing the notion of a version of record. And that's also something that's driving people to kind of jump up and down. So there's no version of record. What does that mean in terms of citations, right?
It's funny. Did you see on their website, they actually, there's this image on the front page that actually has like this 5-step process. And the 5th one is actually a version of record, which is in green. So I now wonder if the version of record that they're indicating there, so how does that relate to their future peer review model?
I'm super curious about that. I'm really curious about that. Look, so submission, peer review, publication, so it's published and the authors revise if they don't. Essentially, it's almost as if, so what do we know? The version of record is an act of speech by publishers, right? That's how the version of record is defined. So publisher says, this is the version of record, right? In terms of how it's created. And then on the back end, well, it's like you registered UI, you get the UI on Crossref, you had a publication, you had a bunch of metadata, blah, blah, blah. It becomes a version of record. But what they're essentially doing is like, hey, publication happens just after peer review, regardless of whether or not you revise your paper. And the version of record and the way they're doing it could be something that is an act of speech of the authors, right? Not by the scientific publisher. I'm really curious. I'd love to have Michael Eisen, the editor-in-chief, one day and have a conversation with him. I'd love to understand how he's thinking about these things.
Same. We should actually try to get him on our Future for Science seminar. This would be really, really cool.
Oh yeah, I think he would be an absolute great person to have there.
Yeah.
He's really deeply into all of these topics, and what he's been doing there is not only, I mean, it's incredibly bold, and you need someone to be very courageous to attempt these types of experiments, right?
Very much so. I have the deep respect and admiration for what they're doing.
No, yeah, me too. No, it's really fantastic. Yeah, so that's the little aside on eLife. I think we can dive into the concept of gateways here. We might even use eLife as a model to illustrate what this means. So essentially, the concept of gateways is you think about that there's no longer like one database that is storing, let's say, all the PDFs, one database that's storing all the code, GitHub, one database that's storing all the videos, conferences and so on, so forth. But rather what you have is you have an open state repository. So that means there's essentially a sea of data, there's a sea of different digital objects that are universally accessible through a universal API. And anyone can write on that essentially vast plasma of information. And everyone writes on that plasma of information and keeps growing this open state repository without having any sort of capabilities to, cut off this API, right? So it's not possible to cut off the access to this open state repository. It's a permanent API because it's stored in an open index. And so what essentially happens is that you have the possibilities to create gateways to access that open state repository, both by writing and reading on this Dataverse. And so what I mean by that is essentially you can spin up a gateway, and you could call it, for example, a preprint platform. And you might call it, the longevity preprint platform or the neuroscience preprint platform. You can thematic, you can make it more generalized. And anytime someone creates a preprint, essentially that preprint is not stored on a local database that's served by AWS or servers at Cornell. It just happens to be into that open state repository. And now everyone else is able to access that open state repository in a way that is completely open. And what this allows to do is it creates a tremendous abilities for applications to compete for features and not for data, right? So you're unbundling the data layer from the application layer. And that changes the incentives. It's no longer about, hey, creating network effects like in Web 2, when you're essentially building, hoarding data and creating network effects out of this hoard of data that you're building out over time, but rather, because you've unbundled the data layer from the application layer, it's all about how are you going to serve your users the best with the best set of features in terms of discovering research, in terms of creating research objects with new and interesting data models, in terms of providing compute capabilities on top of these research objects. So essentially, it creates like a free market for applications that are there to serve the user, which cannot benefit from creating monopoly access around the data that is stored in these applications, right? So that's a really interesting idea because it naturally prevents the emergence of data silos and systems like we've seen very, very much. This is the history of Web 2 in a way. It's like these big social networks and platforms, they were open, they had APIs so developers can come in and build, you could build games on Facebook and get distribution. You could build network aggregators, social network aggregators on Twitter. You had all sorts of rich API access that developers could build on, and they build on all these companies, startups, nonprofits, research labs. They were essentially using all of that data to create value. And what happens slowly over time is as these network effects built around data consolidated, So as the network effects built around data consolidated, there was a push to close off these APIs. And so these APIs became closed off. A lot of companies couldn't do their business because they lost the ability to interact with these backends. And what happens is what we have today. We have these hyper powerful Web2 social giants that tightly control the type of things you can build, the type of usage of the data based on their API terms, the amount of data that can be used, the richness of the features, and essentially it's keeping everyone at their mercy, right? So that's the type of structure that the decentralized web can fundamentally disrupt, right? With these ideas of decoupling application from data layers to create a different set of incentives for application builders. So if we go back in the context of science, we can think of Elsevier as one of those Web2 giants, right? They're very, very similar to Facebook in a way. They have incredibly strong network effects. They have internal database and data reconciliation system. They even brand themselves as a data company. Like Elsevier is no longer a scientific publisher. It's branding themselves as a data intelligence company. And that's to say that their biggest value proposition, and their entire business is aware of that, it has to do around data aggregation, proprietary data aggregation. And they create tremendous value for their shareholders with that system. We don't want that in the future. Whatever system of science comes to replace the silos that we have today should not be capable of creating these tremendously powerful and unfair network effects around data that tend to monopolize information and prevent others from building and extending these scientific repository. And so that's a big part. And to put this into perhaps less abstract words, imagine if all the preprint platforms in the world, data repositories, current information research management systems, these are the systems used to track outputs from researchers, even grant management systems. What if all of this backend was essentially writing and reading on a completely open dataverse? And you could imagine all of a sudden a tremendous ability to link back information, to find information, and to interoperate on information. So for example, you could create, there's this name in the jargon of semantic web /science. It's called PID graphs, PID graphs, right? This is the idea of creating linked data graphs of like, hey, all the research associated with this researcher, all of the research, the code, the data components, how all of these interact and are being reused by other research objects. So one of the great benefits of this type of architecture is that it tremendously accelerates ease of interoperability with the underlying artifacts that are stored on this open state repository. And another real benefit is that you don't think about it as essentially a large database, but you think about it as a protocol, right? And the rules of the protocol is essentially, well, there's a certain way you write on this repository to create a valid manifest file. And you could imagine having a lot of different, community-based definition of how they want to build a research object, how they believe that these research objects should be labeled, the type of metadata that should accompany them. And that's all fine, because you can actually take this modular metadata systems, and because you're using a self-describing data model, which essentially means that when you pull the data from the repository, just by reading through, whatever JSON, whatever digital object comes back, you understand, what are the categories, what's the data model that's being used, what are the terms that are being used to describe the artifacts. You have that semantic cohesion that makes it machine readable. And now communities themselves that run these gateways can come up with their own valid type of manifest specification so that they can essentially tweak and customize it in a very, very simple way without having to rewrite the entire backend of the scientific record every time, which is what we need today, right? Which is to say, metadata standards nowadays is going to be Dublin core, and it's going to take 5 years for an expert agreement to agree to arrive on a conclusion of what should be in a scientific in the data model of the scientific record, right? So to sum up, we unbundle the data from the application layer, we create a permanent API that allows any application to read and write on this data. We have a protocol which defines the type of valid manifest file that can be written there. We have within that manifest file, communities can create their own data models, provided it's all self-described and fits within that specification. And that creates, ease of upgradability. Now, one of the super exciting things about that is now we have a common namespace for PIDs, permanent persistent identifiers, right? And we have a new class of PIDs, which we call decentralized identifiers for linked data objects, which essentially allows us to turbo scale what today is, the DOI system, digital object identifiers. So essentially you could think of that as the master key to the scientific record. It's centralized, it's poorly scalable. It doesn't allow us, it breaks, right? Because these are not structures which are immune to content drift. Whereas anything that's on that open state repository is immune to content drift, meaning that the content of the data stored cannot change without the address of that data object changing. That's called content identified resources, right? So you have protection against content drift. You have the ability to upgrade those manifests at the community level. You have an incredible level of interoperability that can be unlocked from there. And any builder that wants to say, hey, I'd like to create an application to interact with the scientific record, they can just go out there, deploy the open source code, build up their application. They can read and write off this record. They can have their community define their own data models. They can provide, any type of value that they want to whatever community they're serving. So if they want to say, hey, I want to provide value and discoverability in search, well, they can come up with new, Elasticsearch systems, new ways of indexing that data in decentralized manners or centralized manner, doesn't really matter. You could be like, hey, I want to serve libraries. Or, hey, I want to serve, funders and philanthropes, and so they can see, where their research dollars are being spent and what's coming out of it. You could be like, hey, I want to serve, the public and provide them a window to essentially interact with the scientific object and maybe, fund future research. You can create interoperability with things like hyper certificates and impact certificates, to fund research. So it really opens up an entire world of possibilities. So that's the basic idea around gateways, and really excited to hear your thoughts about that.
Yeah, super cool, Chris. So from my perspective, when I'm thinking about gateways, I primarily think of them as basically the new way how we can do content curation for a completely open scientific record, right? So we will have this world of nodes that are all in the public domain, that are all stored on IPFS, that are mirrored, that are freely available and permanently indexed. And now the big problem is, how do you find the stuff that is actually relevant? How do you find the stuff that is actually good? And for that, you need a curation device. And the gateways are one way to do that, right? So when you run a gateway, you can basically say, this is the type of content that I'm interested in, or that my organization is sponsoring, or that my organization is interested in. And then you just display that content, right? So you can go ahead, for example, as a university, you can say, here's all the fantastic work that the people at my university have been publishing. Or as a funding agency, you can go ahead and you can say, here's all the work that we have funded that our researchers have actually produced. Or as, like I say, a foundation that is sponsoring Alzheimer's research, you can say, well, here is a gateway that displays all the relevant Alzheimer research. Or as a journal like eLife, you could run a gateway and you can say, here are all the articles, here's all the research that satisfies our publication criteria, and we're going to display it. And it's basically, it's really just a curation device that helps readers find the stuff that is most relevant for them. And for those that actually work in science or that are engaged in science, to actually engage in the process of curating content. So that's how I'm thinking about it.
Yeah, I mean, it could very well be that the prime value proposition for many, many gateways is the process of curation. And you could imagine gateways that run algorithms to create custom feeds for scientific communities to optimize the type of content that they're exposed to. Yeah, we could really there's a case to be made that a lot of the value is in curation, and that's going to be one of the prime application of these gateways.
There's so much more too, right? Like the different apps that you were describing, Chris, the different things you can do when you have access to this you have access to open state repository of all the knowledge we have. You can build apps. Like we can't even imagine what's going to happen when you can just play with the knowledge that we have. And it's
Yeah, I mean, I think it's staggering, and a lot of it we can't even begin to imagine today, right? So, like, think of the interaction with decentralized compute. Every research object that's stored as a DeSci node on this open dataverse, essentially, in principle, can be interacted with using Bacala or decentralized compute solutions. And that means you can take the data that's been posted in a node. Let's say, it's geospatial data, it's the surface of the moon, and you could say, hey, could you, segment that picture for me, right? And you could run like a segmentation command from a toolbox you import in Python or something like that. And that, segmentation command is run on that data. It contains, the pictures of the moon's surface from a paper in astrophysics and planetary science. And what happens is then it like outputs a hash that it codes that new data set that's been transformed, and it has metadata saying what types of transformations has happened on that data set. So all of a sudden, rather than having to as a researcher and scientist needing to like download all your data locally or put it in your local server at the university, wherever you are, you could start just interacting with that data in the cloud and creating these traces of transformed data with labels. And you could think of Bacalhau, or decentralized compute as almost like a form of, as its own type of gateway, right? It's like a gateway towards, for cloud computing on an open state repository. And you can now imagine people, building out completely new findings, completely new ideas from these types of, more computational oriented gateways, right? So you can have curation, you can have computation, you can have mechanisms to store large data sets. You could have search engine optimization, all sorts of really fascinating types of applications that can be built on top of it.
Totally. And what I would really love to see is a gateway that displays reproducible research or actually replicated research. Wouldn't that be cool if there would be one place where you can just go to find all the stuff that was actually replicated or where people actually attempted a replication? Something like that.
Yeah, I think that's more that's so the way we're thinking about it right now is that this is actually, whether your work has been replicated or not is part of the manifest file, right? So it's part of the spec and DeSci nodes. So essentially, it's not going to be the case for the open beta, but soon later on, we want to be able to surface work that have replications. And so that's imagine the power of being able to search these types of databases where, you have super valuable cues about that research. For example, is the work reproducible? Are the artifacts available? Is the data in the open domain? And you have all these provable cues, bits of information that allow any types of search function on top of that record to be quite supremely customizable, right? And very rich in the type of data that can return.
Yeah.
The value, Philip, that you're describing, though, the ability to build a gateway that develops requirements for the content it decides to surface we can't describe it yet. It redefines how incentives in these systems will work.
Exactly.
And if I build a gateway that says, and I build a good gateway that people want to go to, and I say I only surface content that does X, Y, and Z.
Yep.
Researchers whoever wants to get on that gateway are going to do X, Y, and Z. And at the same time, because it's built on this open state repository, a competitor can spring up right next to me and say, okay, I'm building a gateway where you have to do X, Y, and Z and A, B, and C. And now we're competing on an incentive layer. No longer, we don't need to compete with data. We compete with incentives.
Exactly. And then there's also like curation in principle, it could be done by humans, like it currently is in the journal system where you have editors and referees, or it can be done by machines based on metadata or search algorithms. or by a combination of both, right? So you can totally, like, there is an entire landscape of new ways how we can actually curate and slice the scientific records in ways that actually creates value for the scientific community and for the public. So I think there is a lot of like really cool stuff that we will be able to build on this very simple idea of just having a gateway that pins specific research nodes that are available on this open network.
Yeah, and it's so simple. Like, I've actually built a gateway in a different life. I work with a different protocol, and it's a very similar concept to what DeSci Labs is building with an open state repository. It doesn't use scientific records. It uses content creation, like videos and whatnot. And I've built a gateway into that lake of content and decided to surface only videos that talk about science in a positive light, right? And it brings value to that community. Other people surface other things. I surface this, and someone else, and whatever works.
Yeah.
And the beauty is there's no one to cut you off, right?
Exactly.
Yep.
So there's no Elsevier to send you a $32 bill for accessing that PDF, right? That just doesn't work because you can't, right? And that's super powerful.
Exactly.
So it really kind of redefines and reshapes the entire incentive structures around product development that touch the scientific record.
Yeah.
Which I think we can all agree is a tremendously valuable public good, and it should be accessible, in a fair way.
Totally.
And you glanced over something earlier, Chris, that I think is really important. We're going to be accessing this data on the cloud and not on someone else's database, and the institutions themselves are not going to have to house data on their own database. So ultimately, we're just increasing efficiency and reducing cost. Like, when you boil down to the economics, and it's going to free resources up to do other more interesting stuff.
Yeah, I mean, this is one of the really some of the really crazy stuff, right? Really space age things is you could start having, let's say, planetary scale, very, very large data, for example, on climate change or these tremendously large, multi-terabyte to petabyte data set that are essentially very, very hard to transfer between institutions. They're difficult to host. They're so expensive to make available to researchers. It's essentially a big challenge, right? You end up, airlifting air drives. And here you'd have the ability for all these communities for whom this data is relevant to essentially be able to crunch that data, to create new data outputs from that data that are themselves, anchored in a common namespace with hashes and metadata. These outputs themselves are fair digital objects that might be tied to scientific publications, that might be, connected to this vast and rich graph of knowledge. And all of a sudden, you have almost like it's science, but it's multiplayer. It's incredibly scalable in terms of data manipulation, data storage across communities, and that could change. That could fundamentally alter a lot of how research that employs large data set is computationally intensive. How a lot of this is done today.
Crazy, Matthew. I think I saw you want to jump in here.
Sure. Sorry. Yeah, it's just such a good conversation going on. I just wanted to add, I think in the incentive idea, the incentive layer, and I'm curious whether this is one of the major things we think we'll see in gateways, or if we'll see it somewhere else. But, I could make a gateway, and I could also, one of the incentives to be on my gateway, might be tokens or funding or tipping or something like that. I might create a gateway that has, a tipping functionality so that anybody who reads, can do that. Or maybe there's a token protocol to it so that everything that gets published or based on views, gets an allocation of tokens every so often. And so I just, I don't know, I guess I wonder, is this part of the vision of the gateways, that I can, this is now the layer that I would add all those additional tokens and incentives and whatever functions like that.
I mean, absolutely. You could think of that open dataverse as like the primitive to allow this to happen, right? So before we can allow this to happen, you need to have some sort of database that links scientist identity with cryptographic keys, public keys, and to outputs, right? Outputs or grant proposals or things like this, right? So you need that kind of like base graph to start with, and we do that. So we'll have that base graph. That means you can build a gateway that says, hey, I want to do surgical airdrops, right? I can. All of a sudden I can, because I have all of this information at my fingertip. So I can start funding science in a completely different way. You could start creating passive income for scientists, right? That meet certain criteria that your community wants to support, your philanthropic community wants to support. Maybe let's say your patient group, right? You work on multiple sclerosis, and you have a prize, right? You have a prize, for great great promising preclinical studies or new types of drug targets. And when you see people are actually come up with these new drug targets, and there's the first thing you might say is like, okay, well, big if true, let's put a replication bounty. So immediately you have like a replication bounty that's like earmarked for specific scientific community you trust to conduct replication. You could say, well, if work replicates, then thank you. You've done a tremendous service to my community by creating that public good of knowledge. Here is essentially a stipend, for so many years, to reward you for having done that. So all of a sudden, because we have that completely transparent trace of provenance, from the scientist to his work, to the possibilities of interacting with the work itself to verify if it replicates, to gather, editorial assessment, peer review reports and whatnot. Because you have that chain here, you can start doing exactly like you say. You could create these incentive layers that essentially fulfill the goals of these specific communities in terms of, providing funding opportunities, providing rewards, providing all sorts of benefits that ultimately would allow scientists to recapture, the value they create in the world.
Yeah, this goes back to the app you were talking about, Chris, because when everyone has access to that same resource, and the resource in this situation is scientific knowledge, you build different business models and ways to profit, display, or whatever with this resource. So people will find ways to make money off of it and then recirculate that money back through the system in unique and novel ways that fund what they want to see funded. And the crazy cool thing with this, because I know funding can be very scary, like the idea of injecting money into these systems can be scary. Like, what if people just turn into the next Google or turn into the next Facebook, some sort of data silo, or the next Elsevier? Well, you can't. If there's a gateway that does something that people don't like, you just don't go to that gateway and spin up your own gateway. Like I said, I've built one of these. They're very simple to put together. I didn't do the technical stuff, but I talked with someone who could do it, and it was their first time playing with the technology, and they just spun it up in probably like 3 weeks. It's not that difficult, and it just takes Google's own phrase, don't be evil, and it just says, well, you can't be evil. If you're evil, people leave, and they'll do their own thing.
Yeah, exactly. I think that's a great way of putting it. Yeah, exactly. You can build your own gateway if you don't like the gateways that are existing. Communities can easily fork. There's definitely a lot of really hard to imagine, but very interesting effects that start to happen. Although we have to say, for all this great excitement and this super powerful vision that can happen out of this, there is a stark, cold start problem, right? And because we're talking about things that happen once you are the data silo, right? Except you're not a silo, you're an open dataverse. And it's almost like, Elsevier could turn into, an open dataverse in a gateway, and they could like immediately trigger these amazing network effects that would have tremendous good on the entire planet, right? But the way we're starting off, it's not that way. That's why we need to essentially start this Node Steward program, work with other groups when it comes to absorbing, open access scientific work at scale. Start finding all of the ways we can start, taking in that information, building up that reputation, becoming a place where these communities can create these research objects, and that's really, the major challenge that we face, right? It's all about being at the place where initially you don't have these tremendously interesting network effects that appear, but you have that cold start problem. And this is what we really need to solve as a community. That's going to be our biggest challenge, and this is our biggest hope, because we know that if we can attract very high quality, high profile research and scientists, we have the possibility of really changing how things are done for the better.
Totally agree. I just had this weird idea going back to this incentive conversation that we had. So there may also be a gateway that is run by a funding institution or by a nonprofit that has a prize or like research funding available. And they could run a gateway where whenever they pin content, they just wrap an impact certificate around that and basically make that particular piece of content eligible to participate in a retroactive funding mechanism that they set up. Right, so stuff like that is going to be totally feasible once we have gateways and research nodes and all that.
Yeah, I mean the interoperability is tremendous, right? Because anyone can set up a contract that essentially restates to let's say create the type of composability you have in DeFi. And that's going to be tremendously interesting because it's a much richer composability. It's not just about monies transformed, right? This is really DeFi. It's monies transformed. It's like you have some sort of token that represents something, and it's wrapped in another token that represents something plus something else, et cetera, right? You have that like composability of monies. And when you think about composability of data, it can actually be really rich. And there's all sorts of things you can attach to these research objects, right? You can attach funding opportunities, impact certificates, hypercerts, these types of things. You can attach, aggregator, data aggregators. You could say, hey, you want to connect an altmetric model to your research object. Well, there you go. You can just connect it, right? That's something that essentially, you could. In the long run, you can imagine this going through an oracle, but in the immediate term, you just have that on a centralized place, and it's just feeding in data that goes into that node. And so you can.
I think we may have lost Chris.
Have all sorts of incentive systems. You could have IPNFTs. You could have hyper certificates, impact certificates, prizes. It can happen at the level of the code and the data that's stored, right? You can use the PIDs, the persistent identifiers of these research objects directly into your code to import data, to transform data, to interact with Bacala, with decentralized computes, right? So there's that data and code interoperability and composability. And then there's the data model itself, right? You can imagine, attaching different types of metrics, alerts, or things that people care about. And that really creates, a very rich ecosystems of truly composable research at many level, right? In terms of composability of funding, composability of artifact reuse, composability of metrics, and you could create, these plural, this rich pluralistic landscape of modular tools and Lego block that you can connect to create, things that are truly extremely interesting, not only for scientists, but for funders, for philanthropists, for society at large.
This makes me wonder, like, with if there's a bunch of these gateways that you're describing pop up that try to highlight the good research, are we changing the incentive of the entire system? Are we shifting it away from translatable research into foundational research? Because my goal will be to get on as many of these gateways that highlight me, give me hyper certificates based on like how many citations I get or whatever. My goal is to get on all those gateways, not so much make the next cure for balding or something like that. I want to be foundational research that supports so much more research ahead of me.
I think a lot of it is going to be. There's going to be different funding mechanisms for research at different stages, right? So you could think of hyper certificates perhaps as more appropriate, or not even, but they're very appropriate for foundational research. Whereas things like IPNFTs, of course, are some things that are specifically applied to much later state research, especially in the life science. So I think there's going to be different niches. that are, a lot of them are going to be replicating the type of funding structures we already have today, but there's going to be these new funding models as well, like these plural funding models that are going to be emerging around them, that are going to be, some of them favorizing the type of foundational research, others looking more at translational work, and it's going to be a rich plural ecosystem, right? So, as a scientist, when you go into that world, you'll have, whatever the world you're operating in, whatever type of funding it's depending on, you'll have other opportunities around with different funding models that you can get to try out, right? And hopefully they'll add value to your lab and allow you to carry on the type of excellent research you want to carry on.
Totally. And I also think that the emerging gateways, they will obviously target different audiences, and they will quite likely also differ in their reputation that they have, right? So I could totally imagine that there's going to be some gateways emerging that are so well curated that they will just be very appealing to researchers, right? So that researchers will try to create research objects that fit that bill just to be featured by that particular gateway, right? So in a very similar way, how you're now trying to get into the high glam journals, that could probably also be something that is emerging in the future. And, they will serve different audiences and different needs.
It's going to be fun. Guys, I see you unmuted again. Go for it.
No worries. No, I'd like to. I'm not pushy. I'll wait for conversation to cool down. But no, I think additionally, you were talking about better and better research. I imagine we'll also see more communicable research and maybe better science communication. I imagine there will be gateways that I could make a gateway that's curated by things that the general public could read, and if it's successful and it's, we get a lot of funding, I could see, and I wonder, whether there might become a shift there, or, if people publish two things, a technical and a communication piece. But yeah.
Well, here's the crazy part with how nodes work specifically. Like the annotations that you can put in nodes, the idea that you can tie like a YouTube video directly to the PDF makes it so much easier to develop and share science communication material. And then as a curator, it'll make it easier to find research that has that material in it. So I could totally see someone, any public community or people like Bill Nye or Neil deGrasse Tyson, like communicators, high-tier communicators themselves, developing a portal that highlights research that either where the researcher themselves or maybe the institution that funded the research or any funder behind the research hired a communicator to develop this material. So these gateways supported by these big communicators themselves highlight the specific research. And by highlighting that research in this communication gateway, those researchers get more funding. So scientists might be incentivized to develop these materials just because funders can understand the research that's on these gateways. It was very difficult to say, but I think I got the main idea across. It would be great. I would love to see it.
Yeah, so next step, we'll have to get busy building and start making some of this reality become more and more concrete, so that people can really get a grasp of for this overall architecture and what is its capabilities. And yeah, I mean, if you guys have, I really enjoyed people to look at the Node Steward program. I think that's going to be an extraordinary opportunity. It's essentially a way to test that, not just to test the system, but to really bring into being extraordinary research objects and essentially break the ice, create scout ahead, right, in the world and find these great scientific objects that could add, tremendous value to this repository to help us, gather not only eyeballs, but create a following of other scientists that want to add their work in this open state repository that we really can then, start to grow and create that not only strong community, but an enduring solution that gets built out over time and just adds value in a compounding way. So if there's any questions about different things we talked about, I think we can take one or two questions, and after that we should probably get to the next call.
Yes.
All right. Well, seeing nobody on mute, I'm going to go ahead and assume that we're good for the call today. Thank you, everyone, for joining. This will be up on YouTube shortly.
So
Thank you, everyone.
This was fun.